Welcome back to another exciting session of science. Before we go over the answers to these questions that I told you to look at yesterday, there's a short video clip that I want to show you on Charles's law. So we're going to take a look at that and we'll come back and take a look at these questions. Okay, so in this video, we're going to explore Charles's law. And remember, Charles changed his temperature. So what he basically said is, as the temperature of gas increases, the volume increases. And as we said in the notes, this is another example of thermal expansion. As the particles move faster and faster, they're moving slow, they're not taking up much space. Faster they move, the more space they take up. If they're in a container, they're going to run into the side of the container harder, and they're going to make the container get bigger. In this case, it's going to be a balloon.
Charles' law states that in a closed system, temperature and volume change proportionally to one another. That is, as temperature increases, so does volume, and vice versa.
The equipment we need for this episode is a heat-resistant beaker or glass,
Some balloons,
some boiling water,
and a fridge or freezer to cool our balloons in. In this experiment, we're going to be using boiling water, so for safety reasons, we highly recommend the use of goggles, temperature-resistant gloves, and an apron or lab coat to protect from spills and splashes. The first step in our experiment is going to be to blow up our balloon. Now, if you watched our previous episode, we're going to want to blow it up a little bit more this time. Like so. I'm just going to tie it off like so. There you go.
The next step in our experiment is to pour boiling water into our glass beaker. Place your balloon into the beaker. In our first attempt at this experiment, we used a water balloon in boiling water. As the water balloon sits on top of the boiling water, it gradually increases in size. There's only one problem with a water balloon. They tend to pop because of their small size. In our second attempt, we used a full-size 12-inch party balloon and less water. We also placed a lid on the top to contain the hot air inside the beaker. In this version of our experiment, we see a more dramatic change in the balloon's size, as well as a much lower risk of the balloon popping. For the second portion of our experiment, we're going to place a balloon into the freezer. Leave your balloon in the freezer for a few hours. After a couple of hours, when we remove our balloon from the freezer, we'll notice it's smaller in size. As it warms up, it will gradually increase in size. Let's look at this experiment a little closer. Charles' gas law states that when a fixed amount or mass of an ideal gas is kept at a constant pressure and in a closed system, then its temperature and volume are directly proportional. What this means is, when temperature increases, volume increases, or as temperature decreases, volume decreases. As we mentioned in our last episode, an ideal gas is a theoretical gas composed of a set of randomly moving, non-interacting particles. Under normal conditions, many gases such as oxygen, hydrogen, and some heavier gases like carbon dioxide will behave like an ideal gas. This means they follow the laws of gases such as Charles' law. In our experiment, our balloon is filled with gaseous air molecules. When the balloon is placed in the beaker with boiling water, the energy from the higher temperature water and
Okay, so the arrows going into the balloon are showing that the heat from the surrounding area is transferring into the balloon. That's going to give energy to these particles. These particles are going to move faster. They're going to bump into the side of the balloon harder, and they're going to cause the balloon to get larger.
steam molecules transfer to the lower temperature air molecules inside our balloon, exciting them. When the air molecules in our balloon are excited by raising their temperature, they spread further and further apart, increasing the volume of space they take up. The higher the temperature or the more energy the air molecules get, the larger our balloon will grow, or in other words, the greater the volume of space our gas will take up. If we remove our balloon from the hot water, the air molecules inside our balloon will gradually lose the...
Notice that the same thing happens to the thermometer. When the particles in the thermometer heated up, the particles in the liquid, they started moving faster, they spread apart more, and then because they spread apart more, the fluid in the thermometer expands and goes up the thermometer. So the thermometer also works the same way on thermal expansion.
The energy they've been given, dropping back to room temperature, causing the balloon to shrink in volume back to its original size. In the second portion of our experiment, we place our balloon in a freezer, which causes a transfer of energy in the form of heat from the warmer air molecules inside our balloon into the cold freezer. As the energy is removed from our air molecules, they slow down, drop in temperature and get closer and closer together, decreasing the volume of space they take up. The colder the air molecules get, the closer together they will be. If the temperature of a gas is lowered low enough, it will go through a change in state from a gas into a liquid. When we remove our balloon from the freezer, the air molecules inside will gradually gain extra energy from the air in the environment, raising its temperature, causing the balloon to increase in volume back to its original size. By changing the temperature of our balloon, we can clearly see the directly proportional relationship between the temperature and volume of an ideal gas. This relationship is known as Charles' law.
All right, so the first question here is the force, pressure is the force per unit of area. And as I explained, if you take something and you apply the same pressure over a tiny area, and this is why nails work. So the top of the nail has a big area where you're going to hit it with a hammer, and the point has a small area where it's going to go through the wood, for example. So when you apply the pressure of the hammer to the top of the nail and the force to the top of the nail, the pressure on that one point where the nail comes to a sharp point is much greater than the pressure that you put on the top. Because on the top, you apply the force to a larger area than the top of the nail. There's another way to think of it. The SI metric unit for pressure is the Pascal. What causes pressure inside a container? This is the whole idea of the kinetic theory. It's those particles bouncing around and hitting the sides of the container. Like we looked on those slides yesterday, particles were inside those different cylinders, and they were bumping into the cylinders and pushing the piston up, or not bumping it as hard and letting it slide down. Okay, so a review of the gas laws. Okay, Boyle didn't boil, so he kept the temperature constant. Okay, and he said as the pressure increases, okay, as you push down on the cylinder, the volume would go down. It would decrease. And then he also said if you decrease the pressure, like they remove some of those weights in those slides, then the volume would increase and the gas would expand. Charles changed the temperature, so he kept the outside pressure on those balloons constant, and he said they go in the same direction. If you increase the temperature, the volume will increase. And if you decrease the temperature, the volume will decrease. So then we said this was basically the idea, the same idea as thermal expansion. As you heat something up, it expands. As you cool it down, as the temperature goes down, it contracts and the volume gets smaller. So we're going to leave off here for today, and I'll see you next time.